those that just joined the class, so the question is from high thermal capacity, high sensitivity, easy readability, accuracy over a wide range of temperature. From the statements above, the qualities of a good thermometer are. So the question falls under temperature and its measurement, just like we said earlier. So, and we're trying to define temperature. So first definition is that temperature is the property that governs the direction of flow of heat. That is, if I have a body that has a temperature of 10 degrees Celsius and I have another body with temperature of 50 degrees Celsius, heat is said to flow from 50 degrees Celsius to 10 degrees Celsius. Just because what? So it is said to flow from hello. Walaikum salam. SS2. SS2 SS2 science àti mathematics kan, math kan, physics kan. Fún lesson, yeah, math and physics, and extramural náà, math and physics. Mo mọ̀ pé bẹ́ẹ̀ ló wà ní. So like I was saying, so when you look at this kind of a body now, that is, if temperature, that is, if it keep flowing from B to A, so what will happen is that it will get to a point whereby they will be at the same temperature, and that will be 30 degrees Celsius. So when the temperature of sun falls to 30, that is, when the temperature of B falls to 30 degrees Celsius, temperature of A would have rise to 30 degrees Celsius. Now, at this point, the rate at which heat is flowing between the two bodies is equal. And that can lead us to the second definition of temperature. That is, the property of a body that determines either or not the body is in thermal equilibrium. Thermal equilibrium with another body contact. With another body in contact. Do you understand this now? Hello, are we together, guys?
Yes, sir.
Yes, sir.
So I hope you understand this now. So when I say a body is at thermal equilibrium, you can either say they are having the same temperature, or you say the rate at which heat is flowing between the two bodies is equal. So thermal equilibrium means the two bodies are in thermal equilibrium if their temperature is the same, or if the rate of heat flow between the two bodies is equal. Or you say when the net flow of heat between the two bodies is zero, or when the resultant flow of heat between the two bodies is zero, you say they are in thermal equilibrium. So examiner can be talking about the law that explains this thermal equilibrium is what we refer to as Zeroth's law of thermodynamics. Zeroth's law of thermodynamics. So that is the law that describes what this thermal equilibrium of a thing. Now, to understand the definition of temperature, what else do we need to know about temperature? Please, is there anybody that doesn't get this definition right? The two definitions. So I want to believe now that we all understand temperature now, right? Okay, so what's the next thing to know? The next thing is to ask ourselves how to determine the temperature of a body. Now, to determine the temperature of a body, we make use of what? The instrument called thermometer. Thermometer is the instrument that we use to measure the temperature of a body. But you see, this thermometer uses a particular substance. That substance has the following characteristics. The substance has the what? The following characteristics. It's sensitive. The substance is what? Sensitive. That's the first characteristics. The second characteristic is what? Easy readability. Readability, accuracy over a wide range of temperature. Accuracy over a wide range of temperature, and it is easily reversible. That is, it is reproducible. Reproducibility. You see, all these characteristics, they are the characteristics of a good thermometric substance. High accuracy over a wide range of temperature, reproducibility, readability, sensitive. Now, when you look at this, we said they are the characteristics of a good thermometric substance. Now, instead of Jamb to ask you that what are the characteristics of a good thermometric substance, they will ask you that what are the characteristics of a good thermometer. So because what makes a thermometer is because of the thermometric substance. So if a thermometer did not have a good thermometric substance, then that thermometer is not going to be a good thermometer. And for a thermometric substance to be a good thermometric substance, it must be sensitive. It must be easily readable. It must be what? Accuracy, high accuracy over a wide range of temperature. It must be reproducible. Are you getting it now? So that is what we refer to as a good thermometric substance. Are we together now? Now, there are other ways that they can use to test all these property. That is, other factors to validate this particular property. For example, if they want to talk about sensitivity, the examiner can decide to use the word low thermal capacity. Low thermal capacity. I see this now. Low thermal capacity means what? It means highly sensitive. Are you getting it now? When something has a low thermal capacity, it means it's highly sensitive. What do you mean by thermal capacity? Thermal capacity is the quantity of heat required to increase the temperature of a body by 1 degree or 1 Kelvin. So if a body now required a very small amount of heat to increase its temperature, that means that the body is sensitive. Are you guys getting this explanation, please?
Yes, sir.
So if a body
Yes,
now
sir.
have what we call high thermal capacity, if a body has high thermal capacity, that means the body require large amount of heat to increase its temperature just by 1 degree. And that would mean what? The body is not sensitive. So high thermal capacity is not going to be what? It's not going to be the factor of a good thermometric substance. But low thermal capacity is going to be factor, because low thermal capacity results to what? High sensitivity. Understand that now. So that's about the property of a thermometer, what we call thermometric substance. So with that, we now look at types of thermometer. Types of thermometer. So when you talk about the types of thermometer, we have different types. And different type of thermometer, they have different thermometric substance. Different thermometer has different thermometric substance. So the very first one that we're going to consider is the liquid in glass thermometer. Now, when you say liquid in glass thermometer, this thermometer, the thermometric substance inside it can either be what? Alcohol or mercury. I'll get it now. Alcohol or mercury. So if you are using alcohol as the thermometric substance, then you are going to call the thermometer, you call it alcohol in glass thermometer. If you are using mercury as the thermometric substance, you call it mercury in glass thermometer. Are we together now? But the name given to either alcohol in glass or mercury in glass thermometer is what we refer to as liquid in glass thermometer. So when somebody asks you, if the examiner asks you that, what is the thermometric substance of a liquid in glass thermometer, then the thermometric substance can either be mercury or alcohol. It can be mercury and alcohol. Are you getting it now? It is what? Either mercury or alcohol. You can't have the two at the same time. So if you are using mercury, it means you are not using what? Alcohol. That makes sense now. Now, what are other questions that they might want to ask? Another question is, what is the thermometric property? Let me clean up the board and try to divide the board into 3. So we have what? The first type of thermometer here, which we called liquid in glass. I said it now, liquid in glass thermometer. Then, what is the thermometric substance? Alcohol or mercury. Alcohol or mercury. What will now be the thermometric property? When I say thermometric property simply means how alcohol or mercury, how they behave to change in temperature. So what happens to alcohol when the temperature of the body increase? And what happens to what? Alcohol when the temperature of the body reduce? So that simply means that the thermometric property for alcohol, that is for liquid in glass thermometer, is what? The increase or change. Oh, sorry, let me use the word change. I think change will be better. The change in of alcohol, the change in volume of alcohol or mercury with a change in temperature. You get that now? So the change in what? The change in volume of mercury or alcohol with a change in temperature is what we refer to as the thermometric property for liquid in glass thermometer. Now, the next one is gas thermometer. We call it constant volume gas thermometer. constant volume gas thermometer. So for constant volume gas thermometer, what do you think is going to be the thermometric substance? What do you think the thermometric substance will be? I'm asking class.
Alcohol.
Alcohol.
The constant body gas.
Did somebody say alcohol?
Yes, sir.
Is alcohol a gas?
Oh,
Constant volume gas thermometer. What do you think the thermometric substance will be?
it should be a gas.
The thermometric
Gas.
substance is going to be gas. Thank you. The thermometric substance is gas. What type of gas are we talking about? So we're supposed to have what we call perfect gas. But perfect gas is not available in practice. There's nothing like perfect gas in practice. So, but gases that are closer to being perfect, are we guys listening? I want you guys to understand this thing very well, so that whatever questions underneath, you don't have any issue with it. Now, we don't have a perfect gas in practice, but gases that we can say they are close to being perfect, they include what? Air, hydrogen, helium. So which other gas do you know? Okay, anyway, air, hydrogen, helium, and nitrogen. These are some gases that are close to being perfect. But you see, out of all these ones that are close to being perfect, hydrogen is the most accurate one among all. But in terms of usage, we use more of what? Helium. Helium is widely used compared to hydrogen or nitrogen. Are you guys understanding this now?
Yes.
So
Yes, sir.
what is now the thermometric property? The thermometric property is the change in pressure, of gas with a change in temperature. What? The change in pressure of the gas with a change in temperature is what we refer to as the thermometric property for constant volume gas thermometer. Do you guys understand this now?
Yes.
Yes, sir.
So the next one, which is the third one, is the thermoelectric thermometer. Thermoelectric, or you call it thermocouple. Thermoelectric thermometer, or you can call it thermocouple. Now, what will be the thermometric substance there? The thermometric substance here, before I can say something is thermocouple, it means you are dealing with two metals of different temperature. Two metals of different temperature. Two metals of different temperature. Are you getting this now? Two metals of different temperature. Now, what will be the thermometric property? Thermometric property is what? The change in electromotive force, between the two metals, between the two metals with a change in temperature. With a change in temperature. You understand this now?
Yes,
Yes,
sir.
sir.
Can I rub this off?
Yes.
So let's look like two more. Like two more.
Sir, example of Thermoelectric or thermocouple.
Example of thermoelectric or thermocouple. What are you saying?
Yes, sir. An example.
When you have two metals of different temperature, any metals of different temperature, so that's the what is it? Thermometric substance. Any metals with different temperature, once you join them together, you can decide to pick what, either iron and iron, but their temperature is different. Then you join them together. Either you pick steel and iron, their temperature is different, but that would be a problem
Sir.
because they have different expansivity. So
Oh,
pick two metals of different temperature. Anything metals of different temperature, join them together, they form what we call thermocouple.
okay.
So the next one is resistance thermometer. So what will be the thermometric substance here for resistance thermometer?
Resistance wire.
Resistance wire. Okay, any other one? Anything aside from that? Resistance wire.
Current.
Current. Okay, somebody say current. Let's take one more. Which other person? What do you think is going to be? Nuhu, Andrew. Let's hear from you.
So I said resistance wire.
You said resistance wire. Okay.
Yes, sir.
What about Maria?
Alloy.
You there?
No idea.
No idea. Okay. Nuhu, are you there?
Yes, sir. Yes, sir.
Or with the thermometric substance?
The resistance wire.
Okay. You also go with resistance wire. Okay. Is this DJ in class? It's one DJ.
Yes, I'm in class.
Okay. So what do you think is going to be? What's your own suggestion?
A current.
Correct. All right. Now we all tried. But you see, when I say thermometric substance, the resistance wire, there's nothing like resistance wire. Because resistance, it simply means an opposition offered by a conductor to the flow of current. So any conductor, anything conductor would do what? Anything conductor would have what we call resistance. It's just like you now, you are a child to your parents, isn't it? But there are times whereby maybe you are watching movie or you are just so relaxed and they want to send you message. That reluctance for you to go and message, are you getting it? That reluctance that you are going to feel is the resistance. Though you are still going to go, but that unwillingness to do it is the resistance. So the same thing goes to all these conductors that conduct electricity. They also have that reluctance in them. So they offer an opposition to the flow of current. Is that taken out? So for that reason, we look for a material that has a direct relationship with temperature and resistance. That is a material that once temperature increase, the what's it called? The resistance will also increase. And when temperature reduce, the resistance will also reduce. And that means we are looking for a material that obeys Ohm's law, and that will be a pure metal. Do you guys understand this now? For resistance thermometer, the thermometric substance there is what? A pure metal. But before I move on, there's one crazy thing that Jamb always do. Instead of Jamb to give you pure metal, Jamb can give you platinum wire. Now, they can give you platinum, they can give you Constantine wires, and so on like that. So you should know that they are still referring to what? Metal. Are you getting this explanation right?
Yes, sir.
Okay.
Yes, sir.
All right. So what will now be the thermometric property? Who can guess? Using the ones that we have been stating since, can you just state something about this? I just want this class to be as interactive as possible. That's when we can remember a lot of things said in the class. Who can help us with that? Nobody? Don't shy. I'm not seeing you where you are now. So just say whatever you want to say. I cannot beat you. Can you just cast something for the thermometric property?
Change of currents between metals.
The change of currents between metals. We are having just one metal here, so it's not going to be between anything. We're having just a metal.
Change of currents.
Change in resistivity.
Change in resistivity.
With
Okay,
temperature.
I think we should start clearing some certain things for ourselves now so that we get a better understanding of physics. When you say resistivity is a constant resistance offered by a conductor. Are you getting it now? That is a specific amount of resistance that a conductor can offer. For example, if they tell you that this thing is a copper, for every copper, they have a specific amount of resistance in them. For anything silver, they have a specific amount. That's when you can now compare which one is a better conductor between copper and silver. Between what? Silver and aluminum. You check their resistivity. So the one with high resistivity is going to be a bad conductor compared to what? The one with low resistivity. So do you understand that now? Resistivity is constant. It has nothing to do with either increase or decrease in temperature. Guys, do you understand that now?
Yes, sir.
All right. So, let me take one more. Okay. Can somebody say current the only time? It can be current, of course. Who wants to say something else before we go on? Let's just make it interactive so that we can share a lot.
Change in resistance of pure metals
Okay, right on. Is that all?
with respect to temperature.
All right. Let's applause. If you can clap where you are, drop your phone and clap for us. So, thank you so much, Ajoke, and thank you others also for contributing to the class. So we said what the change in resistance, the change in resistance of pure metal with a change in temperature. Do you get that now? The change in resistance of a pure metal with a change in temperature, that is what we call the thermometric property for a resistance thermometer. You guys understand this now? All right, so the last but not the least, we have more type of thermometer. Just list these 5 that are very common. So the next one is bimetallic thermometer. So who can tell us what will be the thermometric substance? Thermometer.
Two metals.
Two what?
Metals.
Two metals. Just 2 metals. Is it just 2 metals?
Yes, sir. Or
Okay.
probably an alloy.
Okay, an alloy. Okay. Is that anybody that wants to help us there? You know, if something is an alloy, it's something that has what's it called? A dual nature. It can be conductor or an insulator. So I don't think that would be a very good example there. Yeah, I don't think that would be a very good example for that.
So out of the 2 metals.
The 2 metals can be a very good example, but there's something missing there. There's something missing there. I think can you help us?
Pure metals.
Pure metals. Okay, I think pure metal. You see the word bi? They're talking about 2 things there. Just like Andrew stated that 2 metal, but there's something missing within the 2 metals. Maria, can you help us?
Change in expansion of 2 metals with temperature.
That will be the thermometric property. That will be the thermometric property. Okay, DJ, can you help us?
Resistance that is in between the two metals.
The resistance that is in between the two metal. Okay. Okay. That's the brilliant one, but I don't think that's going to work fine. We have in this class. I'm not really okay. It's
Probably two metals of same temperature.
two metals of same temperature. Okay.
Mm.
All right. So let me help us out so that we don't waste much time there. Two metals of different expansivity. So when you have two metals of different expansivity, we talk about what? We talk about the thermometric substance for a bimetallic thermometer. So the thermometric substance will become the change in expansion between change in expansion of two metal with temperature. So do you guys understand this now? So there are other type of thermometer also. And mind you, you see this resistance thermometer, examiner might at times not call it resistance thermometer. They can decide to call it platinum thermometer because the kind of pure metal they always use inside it used to be platinum. So they can call it platinum thermometer, just know that. And the constant volume gas thermometer also, examiner can call it thermodynamics thermometer. Are you getting it now? They can call it what? Thermodynamic thermometer. So you should just try as much as you can to get familiar with their other names. It's going to do you a lot of good. Now, let us try to buttress more on all these thermometers by looking at their advantages over one another. It's very important, especially the liquid in glass thermometer. Especially the liquid glass thermometer. So there's need for us to consider what we refer to as their what? As their advantages and disadvantages. Now, most times, examiners always want to compare the mercury, that is, if I use mercury as my thermometric substance, and I use alcohol as my thermometric substance in a liquid in glass thermometer, what is their advantages over one another? Now, let's talk about the advantage of mercury in glass over alcohol in glass thermometer. Number one is that mercury in glass thermometer, for mercury in glass what? Thermometer, it has a small thermal capacity. Mercury has what? A small thermal capacity compared to alcohol. Are you getting me now? That is, mercury responds to change in heat very faster than alcohol. Are you getting it now? And secondly, mercury does not vaporize. It doesn't vaporize easily. But because alcohol is what? Alcohol is a volatile substance. It vaporizes easily. Are you getting this now? Mercury is not okay. No. That can be a very good advantage of mercury over alcohol. Okay. Another difference is that mercury does not stain glass. Mercury does not stain glass. I get it now, but alcohol does what? Alcohol in glass thermometer does stain glass. So which other one? Okay, mercury thermometer, they can measure a wide range of temperature because the least amount of temperature that mercury in glass thermometer can measure is negative 39 degrees, and they can measure up to 360 degrees. So you can see they can measure a lot, but for alcohol, they can measure from negative 112 to 78 degrees. So alcohol in glass thermometer cannot really measure a very high temperature, but it can measure a very low temperature compared to mercury. Please note this very well because questions do come out under this. So you should know that alcohol is very good to measure a very small amount of temperature, while mercury is very good to measure a very large amount of temperature. Do you understand that now? Hello, do we understand that now?
Yes,
Yes,
sir.
sir.
Now,
Yes,
Yes,
sir.
sir.
the mercury in glass thermometer or mercury itself is linked to a clinical thermometer. When you talk about the thermometric substance of a clinical thermometer, you know clinical thermometer is like a domestic thermometer that they make use of it in hospitals. So for clinical thermometer, the thermometric substance there is mercury. Now, and it ranges within 35 degrees Celsius to 43 degrees Celsius because you're actually using it to measure human being. So you don't expect the temperature of human being to get to 50 degrees Celsius. Something must have been wrong somewhere. I get it now. Or Adeba, you have your measurement, like your temperature up to that amount. Here with us. I think he left. So you get to see this now. It's measured within what? 35 degrees Celsius to 43 degrees Celsius for clinical thermometer. All right. So which other one do you need to know there that they always also want to compare? That's just fine. I think that's just fine. Now, if I move on, there's a particular question that always come up under what's it called, but I think when we get to the next heading now, we are going to explain that. So do you guys understand this aspect of thermometer now?
Yes, sir.
All right.
Yes, sir.
Okay, thank you. So now let's
Yes,
go
sir.
to temperature scales. Temperature scales. Temperature scales. Now, when you talk about the scale of temperature, we are trying to refer to the units of measurement. Now, when you say temperature scale, we are trying to refer to what? Units of measurement. And when you talk about the unit of measurement, we are familiar with these three. Number one, Celsius. Celsius scale. Number two, Fahrenheit. Fahrenheit. Nonsense spelling is always difficult. Fahrenheit scale. And
Kelvin scale.
you see there are three scales of thermometer. Now, when you say Celsius scale has 0 degrees Celsius at the ice point and 100 degree what? Celsius at the steam point. That is, the lower fixed point for a Celsius scale thermometer is 0 degree, and the upper fixed point is 100 degrees Celsius. So you can call the lower fixed point the what? The ice point. Because lower fixed point of a thermometer is the temperature in which what? Water will turn to ice at constant atmospheric pressure. Am I making sense now? And upper fixed point of a temperature scale is the temperature that water will boil or change to steam at what? Constant atmospheric pressure. Am I making sense now? So for Celsius, the lower fixed point is 0 degrees Celsius and the upper fixed point is 100 degrees Celsius. But for Fahrenheit scale, the lower fixed point is 32 degrees Fahrenheit and the upper fixed point is 212 degrees Fahrenheit. Then for Kelvin scale, it is 273 Kelvin and the upper fixed point is 373 Kelvin. Are we together now? Now, let's take for instance that I have a thermometer here, and this place is the lower fixed point, or you call it the ice point. Lower fixed point, or you call it the ice point, and this place is the upper fixed point, or you call it the steam point. Now, the difference between the upper fixed point and the lower fixed point is what we call fundamental interval. Are we together now? The difference between the upper fixed point and the lower fixed point of a temperature scale is called what? Fundamental interval. Are we getting this now?
Yes, sir.
Okay. So if that should be the case now, we can now look at what we call triple point of water. You might be asked that what is triple point of water? Triple point of water. So the temperature at which ice water and water vapor are all in equilibrium. This temperature is called what? The temperature at which ice and water vapor are all in equilibrium. Now, at this point, there's need for me to tell you something about absolute zero. Absolute zero. When you say absolute zero temperature is the lowest temperature that can be measured scientifically, and that is equivalent to 0 Kelvin. Am I making sense now? It's equivalent to what? 0 Kelvin, which is negative 273 degrees Celsius. That's the lowest possible temperature that can be measured. Is that it now? Is that taken?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay.
Yes, sir.
Now, before we go to conversion of scale, there is this famous questions that examiner always want to put through under absolute zero. Examiner can say, define absolute zero temperature. Define what? Absolute zero temperature. You know, when I say absolute zero temperature, we said it is the lowest possible temperature that can be measured scientifically. But if you want to define it in terms of kinetic property of the body, we said what? It is the temperature at which the average kinetic energy, the temperature at which average kinetic energy of particles making up a body is 0. Are you there now? Is the temperature at which the average kinetic energy of particles making up a body is 0. That's what we call absolute zero temperature. Are you getting this now? Or you can as well say it is the what? It is the temperature in which what thermal motion will cease. The temperature at which thermal motion ceases is also referred to as absolute zero. Now, let us now look at conversion of scale. Conversion of scale. So how do you convert from one scale to another? Let's take for instance that I want to convert from Kelvin scale, let me say Celsius scale to Fahrenheit scale. I'll convert from Celsius to Fahrenheit. The first thing you want to do is to draw this. Then you ask yourself, what's the lower fixed point of a Celsius scale? What fixed point of a Celsius scale thermometer is 0 degrees Celsius. And the upper fixed point is 100 degrees Celsius. So let's take for instance that the temperature that we want to convert is C degrees Celsius. You want to convert it to Fahrenheit. So the next question you ask yourself is that, what is the lower fixed point of a Fahrenheit scale? That is 32 degrees Fahrenheit. What's the upper fixed point? That's 212 degrees Fahrenheit. So what will be the temperature? What will be the value of C in degree Fahrenheit? Let's say the value is what? F. So we want to look for the value for F now. How do we go about that? Take the proportion of this. We have what? C minus 0 divided by 100 minus 0. And this is equal to F minus 32 divided by 212 minus 32. So from here,
Yes, sir.
so we have
Yes,
C over 100 to equal F minus 32 divided by 180. So when you cross multiply, you will have 180C divided by what? 100 equal F minus 32. F the solid of the formula. So we have that F is equal to, I think here, 0 can cancel this 0. And 2 can go in 18 9 times, 2 can go in 10 5 times. So we therefore have 9 over 5C plus 32. That will be the formula to convert from degree Celsius to degree Fahrenheit. So anytime you are converting from one temperature scale to another, you always draw what? Their scale. The one you are converting, the one you want to convert first, then the one you are converting to. And examiner at times, they might not even ask you to convert from one unit to another unit. At times, what they do is that they can give you that, okay, the length of mercury thread in this one is maybe 55 millimeter. Then I can ask that, okay, what will be the equivalent of that 55 millimeter in degree Celsius or in degree Fahrenheit or in degree Kelvin? Do you understand that now? So that's about the topic. So before we look at external questions, I would like us to answer this one very quickly before we now look at questions from the pack. So what will be the answer to this? Okay, let me go back to the question. Okay, so the network. Okay, so sorry, network trip off, so I'm trying to reconnect back. Okay.
Okay.
So let me share my
So let me
screen.
share my screen.
All right, so back to the question now. So the question is, Roman figure 1, high thermal capacity. Roman figure 2, high sensitivity. Roman figure 3, easy readability. Roman figure 4, accuracy over a wide range of temperature. So from the statement above, the qualities of a good thermometer are, so which one will be the right answer?
A.
A, that's Roman figure 2, 3, and 4. Do we all agree with him?
Yes,
Yes.
sir.
Yes, sir.
All right. So that's correct. I believe everybody understand this now. So let's see. Let's go and open everybody's let's see how far you understand it. Don't let me use that language. I want to use. So, okay, guys. So now let's see. The first question here states that okay. So the question says absolute zero temperature, absolute zero temperature can be defined as the temperature can be defined as the temperature A at which the average kinetic energy of particles making up a body is zero. At which pure water changes to ice at standard atmospheric pressure. Sorry. At standard atmospheric pressure. Then C, of 0 degree on the Celsius scale. Of 0 degree on Celsius scale. And D, at which pure water and steam exist. Okay, so what will be the right answer there, guys?
A.
A.
A. Okay, so that's absolutely correct. Now let me quickly say something about Jamb options. If you look at option B and option C, you see that they
That
cannot be,
correspond.
because they are the same thing. Thank you for noticing that. They say at which pure water changes to ice at standard atmospheric pressure, which is the same thing as what? 0 degrees Celsius. So you should know that these two can never even be the option. So you should always watch out for that, because it will help you to eliminate the ones that cannot be the answer. In case probably you don't even know what the answer should be. Then at which pure water and steam coexist. So this can be talking about the what? The triple points that we explained the other time. Okay. So the next question here is 2005 question number 14. 2005 question number 14. Roman 1, we have reproducibility. Reproducibility. Figure 2, sensitivity. Roman figure 3, high thermal capacity. Roman figure 4, high accuracy. So the question states that the qualities of a good thermometer include A, Roman figure 2, Roman figure 3, and Roman figure 4. B, Roman figure 1, Roman figure 2, and Roman figure 3. C, Roman figure 1, Roman figure 2, and Roman figure 4. D, Roman figure 1, Roman figure 3, Roman figure 4. So which one is the right answer?
C.
C, correct. Okay, so let's try this. 2001 question number 20, paper type T. The question says the thermometric substance, the thermometric substance, the thermometric substance of an absolute thermometer. Do you know the thermometer they call absolute thermometer? I'm asking, do you guys know the thermometer they call absolute thermometer?
No.
You're talking about the constant volume gas thermometer. So that's the reason why I always ask you guys to solve more questions. You know, I didn't say that in the class. So when you solve questions, you get to know more about all of those things. Teacher can't just cover it all. So alcohol, okay? A, alcohol. B, mercury. C, helium. And D, platinum. Seems my Okay. Network is lagging before because you probably do not see what I'm writing. The meeting just started. Okay, so you can see now. So the thermometric substance of an absolute thermometer is, so which one will be the right answer there?
Mercury.
Mercury.
These three, all of the options.
Helium.
Who said helium?
Me, helium.
Mercury.
Helium.
Mercury.
Okay, well done. All right, the person that says helium, why helium?
Constant volume gas thermometer.
Yeah, because it is the constant volume gas thermometer, and the thermometric substance there is gas that can either be air, nitrogen, hydrogen, or helium, but helium is widely used. So if you look at alcohol and mercury, they belong to the same thing. For you to see alcohol and you see mercury, you know that none of this can be the answer, because they are both thermometric substance for what? Liquid in glass thermometer. So if after you want to make a guess, your guess should be between helium and platinum. I hope you understand this now.
Yes, sir.
Yes, sir.
So the correct
Yes, sir.
answer there is helium. Okay. So let's take another question now. All right, so let's check this one. 1982 question 20. The question states that which of the following features does not increase the sensitivity which of the following features does not increase the sensitivity of a liquid in glass thermometer? Option A, we have a large bulb. Option B, we have a thick wall, walled tube. We have a thin walled tube. And option B, we have a liquid with high expansivity. Okay, so can you answer the question now? The question says that which of the following features does not increase the sensitivity of a liquid in glass thermometer?
B.
D, a liquid with a high expansivity.
No, B.
B,
A thick walled tube.
a thick walled tube. So who also supports R?
B. Sir, the B and the C question, the B and the C is saying the same thing.
A thick walled tube, a thin walled tube. It's not the same.
Okay. B.
All right, so the correct answer there is B. Now, but for those of us, because we didn't mention this in class, but for those of us that doesn't know what really affects the rate of sensitivity of a liquid in glass thermometer, number one, the bulb. The bulb have it to be very large. If the bulb is large and thin wall, large and thin walled, it increases sensitivity. That's one. Two, stem, or what we call tube. Stem or tube with thin walled and narrow bulb. This increase what? The sensitivity. Lastly, liquid with high thermal capacity. Sorry, high expansivity rather. What's thermal capacity? High expansivity. High expansivity. High expansivity. It also do what? It also increases its sensitivity. I believe you all understand that now. Okay. So next question here is year 2010. Year 2010. That's kind of very recent. I want us to answer question till we have some minute more. Year 2010. The question says that one special advantage of alcohol over mercury as a thermometric liquid, A, low freezing points. B, high specific heat capacity. And C, low boiling points. And D, low density.
Low freezing point.
Low freezing point. Do you all agree with him?
D, low density.
Low density. Okay. Another one?
A,
I-
low freezing
I-
point.
Low freezing point.
Low freezing
High
point.
specific heat capacity.
Somebody saying something?
B. High specific heat capacity.
High specific heat capacity. Do you know what it calls specific heat capacity? Let me start from there. Specific heat capacity is the quantity of heat required to increase the temperature of a unit mass of a body through 1 degree or 1 Kelvin. So if a body has a very high specific heat capacity, can that body be a good thermometric substance? Of course, it can be. A body with high heat capacity or high specific heat capacity cannot be a thermometric substance because it's not going to be sensitive. Do you understand that now? And for that person that says density, I don't see how density affects the rate of what is it called, sensitivity or accuracy of a substance. What we always use, what density affects? Density affects the amount of substance that we need, because when you, I think okay, in the last class when we do density and upthrust, I explained that if I have a body that is of length 10 meter, a metal that is length 10 meter, and I have a paper that is length 10 meter, of course, if I measure their weight, the metal will be what? we have a very high mass compared to that of paper. So that's what we use density to do. So you can't say it has something to do with thermometric substance. So absolutely, they only put it there to let the option make sense. So the right option is supposed to be within these two. Are you getting it now? Low freezing point. I told you that the advantage, when we are listing the advantage of mercury over alcohol, if you look at mercury, the lowest temperature that mercury can measure is minus 39 degrees Celsius. I said that in that class, Abi. So any substance that its temperature is lower than minus 39 degrees Celsius, then you cannot use what? Mercury. But alcohol, it can measure up to minus 112 degrees Celsius. That means it's having a very low freezing point. Before alcohol can freeze, start to get to that particular temperature, very small. So that enables us to use alcohol to measure a very small amount of temperature. It's going to detect it. Are you getting that now? So I think this question is like one special advantage of mercury over alcohol. Then the correct answer is going to be what? DJ. If the question is that one special advantage of mercury over alcohol as a thermometric liquid is, what will be the right answer? With the explanation that I gave earlier.
A.
Low freezing point.
Get the question. The question says one special, normal question is one special advantage of alcohol over mercury as a thermometric liquid. Adebayo said the correct answer there is what? Low freezing point, which I agreed with him. Because for mercury, the freezing point is minus 39 degrees Celsius. While for alcohol, it's minus 112 degrees what? Celsius. So that means with this low freezing point, it can measure a very low temperature, of which mercury cannot. Now, I'm not asking you that if the question is one special advantage of mercury, instead of alcohol now, of mercury over alcohol as a thermometric liquid is, what will be the answer? This thing is not
Low boiling point.
going to be low boiling points. No. There won't be answer here. Do you get that now? There won't be answer
High
because
boiling point.
it's supposed to be what? High boiling point. Because it is around 360 degrees. While alcohol is what? 78 degrees. All of this has been stated in the class. Please go through that note again. It will help you to quickly recall all this. Is that taken out?
Yes, sir.
Okay, so let's move on to some questions that has to do with calculation. Because we're running out of time already. All right, 1978. But before 1978, let me ask you guys this question. And let me see how smart you can think. The question is 2009, number 18. The question is, the thermometer whose reading, whose reading is indicated by a change in color, of its thermometric property. Property is the A, bimetallic strip or stripe thermometer. B. Thermocouple. C. Platinum resistance thermometer. D. Optical pyrometer. Okay, so what will be the right answer? The girl says that the thermometer whose reading is indicated by a change in color of its thermometric property is the A. Bimetallic stripe thermometer, B. Thermocouple, C. Platinum resistance thermometer, D. Optical pyrometer. Which one is going to be the right answer there?
D.
D. D.
They are shouting D, D, D like this. Why is it going to be D, Musa? Is it there with us? Okay, Adebayo, can you help us? It seems Musa is not there.
Sir, the bimetallic strip, that one is between two metals of different expansivity.
Okay.
And thermocouple too, it does not deal with change in color.
Okay.
So the only one that is related to change in color is that optical pyrometer.
I'm very glad with your I'm glad with your what's it called, your analysis. But don't tell me that the one that is related to, you tell me that the one that you don't know here is optical pyrometer. So that's what they are going to say. And that's just the simple thing about what's it called? Some Jamb questions. And I can tell you like vividly well, the first time I saw this question, I also don't know about optical pyrometer by then. I don't know anything about optical pyrometer. But how do I answer my question is that the ones I know, I just rule them out. I know this one does not have anything to do that. This one does not. I know definitely the answer will be this. Do you understand that now? And I think that's a very smart move. Thank you, Adebayo, and every other one. Okay. Now let's check this question now. We are running out of time already, but let's just look at this question. Just quickly try it before we go for break, then come back for 5:30. So, okay, a temperature of 20 degrees Celsius, a temperature of 20 degrees Celsius is the same as A, 36 degree Fahrenheit, B, 68 degree Fahrenheit, C, 11.1 degree Fahrenheit, and D, 43.1 degree Fahrenheit. Okay, guys. So what right answer to this? Is anybody solving? Try it. Sharp.
B. 68 Fahrenheit.
68 degree Fahrenheit. Okay, is there any other answer that contradict that? Is Musa there?
68.
68, okay. Adebayo, I'm expecting your answer. Ajoke, I'm expecting your answer. Omotunde,
68.
Omotunde, I'm expecting your answer.
I said 68.
Okay. Is Maria here with us or she has gone for a chemistry class?
I'm here.
Okay. So what's the answer?
68.
Okay, 68. So that's absolutely correct. So the answer is 68. Okay, let's make it complex a bit. The eyes and steam points. The eyes and steam points of an ungraduated thermometer. The eyes and steam points of an ungraduated thermometer are 200 millimeter apart. Calculate the length. Calculate the length above the ice point. The length above the ice point, which will correspond to a temperature of 30 degrees Celsius. 30 degrees Celsius. A, 15 millimeter, 30 millimeter, C, 60 millimeter, and D, 120 millimeter. So we're solving. Quickly give it a try and let's know what your answer will be. So while you are solving that,
C, 60 millimeter.
60 millimeter. Okay, it's an answer. Mostly right. Trying to math. I'm trying.
Yes, sir.
Yeah, I'm trying to get few people's voice.
60
60
millimeter.
I'm familiar with your own voice already. Adebayo, I'm here to hear your
60
voice.
years, sir.
60. DJ, are you still there? The
Yes,
DJ
sir.
there. What's the answer?
60, sir.
60 millimeter. All right. Okay, so that's absolutely correct. Okay. Okay, let's try this. Calculate the length. Calculate the length which correspond. Calculate the length which corresponds to a temperature of 20 degrees Celsius. If the ice and steam points, of an ungraduated thermometer are 400 millimeter apart. Okay. Finish. So you must have started solving like that while I put down the option. So option A.
80.
Okay, somebody say 80. 80 part of the option. Yes, there is 80 in the option. So let's hear from others. If we have the same thing, then that means it should be correct.
80.
80.
80. Yeah, it's
80.
correct.
Okay, okay. I've not heard from the boys. Maybe they are still working.
20.
80. 80.
80. Sorry.
Yeah.
Okay, DJ say 20. Okay, that means we need to solve to check if it is right or wrong. So listen to this question. How do you attempt this? Calculate the length which correspond to a temperature of 20 degrees Celsius if the ice and steam point of an ungraduated thermometer are 400 millimeter apart. Okay, so let's say this is a thermometer that is ungraduated and it is 400 millimeter apart. So this is going to be 0 millimeter and this is going to be what? 400 millimeter. So the temperature we are looking for, let it equal to X. And the one we are comparing it with, what? Degrees Celsius. This will be 0 degrees Celsius. So 20 degrees Celsius will be somewhere here. And here is going to be 100 degrees Celsius. So we take the proportion, that will be X minus 0 divided by 400 minus 0 equal what? 20 minus 0 all over 100 minus 0. DJ, are you following everybody? So that will be X over 400
Yes.
equal 20 over 100. So 20 here 1, 20 here is what? 5.
20.
So if I cross multiply, I will have 5x equal 400. So x is equal to 400 over 5, and that will be 80 millimeter. Are you to spot your mistake, TJ?
Sir.
Are we seeing your mistake?
Yes, sir.
Okay, please avoid that subsequently. Okay. All right, so I think we should be able to stop here. So that's just how to handle any questions on the temperature and its measurement. So let's see what our next topic will be when we come back from the short break that we are going for now, so that everybody that wants to go and pray can go and pray, and those that want to go and eat can go and eat. Okay, so our next question is going to be on machine. Number 12. A machine is used to lift a load of 20 Newton through a height of 10 meters. If the efficiency of the machine is 40%, how much work is done? So when we come back, we look at machine as a topic. So thank you. By once it is let's say 15 minutes to 3, we are going to resume class back. 15 minutes to 3. That's enough. All right, guys. So bye for now.
All right, sir.